What have you looked at so far? You've looked at these new numbers that exist. They're a bit strange, but they do exist. When you learn your new numbers, as always, you know this from primary school, you'll try and add your new numbers, subtract your new numbers, multiply your new numbers, and divide your new numbers. You have been doing adding, subtracting, and multiplying. Before you look at division of your new numbers, which are called complex numbers, I want to do this video where we're going to look at many types of, rewriting or division. So one of the first types of division that you've seen is maybe when you were in primary school and you had 10 and you needed to divide it by 2. Or even just 100 and you needed to divide it by 2. So 2 into 1 doesn't go, 2 into 10 goes 5 times, 2 into 0 goes 0 times. So that's one type of division. You've also looked at long division. Maybe 2 divided into 1, 3, 5, 2, 9, 4. And you'll go, right, 2 into 1 doesn't go, 2 into 13 goes 6 times, the remainder 1, etc. 6 times. And then that's 2 times 6 is 12. My remainder is 1. Or there's another way of doing it that I kind of started off doing there that might be more familiar to you. So you've your just basic division, your long division. All this applies to your algebra as well. You do long division in algebra. You do division to do with fractions, like 10 divided by 2. That's what that means. So maybe you don't realise that, and what you decide is, 2 goes into 2 once, 2 goes into 10 5 times, so that's 5 over 1. What you're really doing there is you're rewriting the number 10 as 5 times 2. You're rewriting the number 2 as 2 times 1. And then you're simplifying to 5 over 1. So there's many, many ways of doing things. What I want to look at today is just another way of rewriting. Not just division or rewriting a fraction like 8 over 10. What is 8 over 10 in its simplest form? Well, 8 is made up of 4 times 2. 10 is made up of 5 times 2. Now that it's in its factors, you can simplify to 4/5. So they're the same thing. They just are written, this is it in its simplest form. So we're allowed to rewrite things in maths all the time. If I had €5 and I multiply that by the number 1, what do I have? I have €5. I haven't done anything to it. Multiplying by the number 1 doesn't actually change it. It might change how it looks. Like the number 1, there's many ways of writing the number 1 even. Think about it. 1 is the same as 10 over 10. 10 out of 10, 1. 5 out of 5. 100 out of 100. They're all the number 1. And multiplying by the number 1 does nothing. Like, this is all just basic primary school maths here. And it's just to have a think about it, because if we want to be able to do division of complex numbers, we need to be able to look at all the different ways that we can do things and work on them and rewrite them if we need to. So to multiply by the number 1 doesn't impact anything. And the number 1 can be it's I'm not going to say mysterious, but it can be written in many, many, many ways. So what I want you to look at just for today, we're not looking at complex numbers at all. I want you to get your calculator. So pause the video if you don't have a calculator with you. Go and look at your calculator, go find it. And I want you to input into your calculator 1 over root 3. And when you have that done, I want you to press equals. What does your calculator say? So I'm giving you time here to make sure that you've paused the video, gone and got your calculator, typed in 1/√3. This is what your calculator would have said. Now, what does this symbol mean? It means they're equal to each other. They're the same as each other. Just like if you type in 10/10, you will press equals and you will get the number 1. They're the same as each other. Why does your calculator do this then? Why does your calculator do this? It's going to always try and write something in its simplest form. And the other issue that is here is that it doesn't like this number on the bottom. Your calculator is just programmed to not have an irrational number on the bottom. So they're exactly the same number. Just if you look on the bottom of your fraction, here you have an irrational number. Here you don't. You have the number 3. So if they're the exact same thing, it just means your calculator is programmed to not have an irrational number on the bottom. But how did your calculator go from here to here? So it took the number 1/√3. How did it get to this? How did it rewrite it? Like, I easily rewrote the number 1 as 10/10. I easily rewrote the number 1 as 5/5. I rewrote the number 8/10 here as 4/5. 10/2, that's 5/1. We rewrite things all the time in maths, but it's about knowing like how. Sometimes we do it so easily and so fast because we've learned it in primary school that we don't even know how we're doing things. We just know it works. So pause the video and see if you can figure out how do they get from 1/√3 to this, to √3/3. What did they do? Okay, I'm assuming that you've paused the video, you've had a chance to try that yourself. What they did was, now there's many ways to do this. One of the most basic ways is they multiplied by the number 1. Multiplying by the number 1 doesn't do anything. It's never going to change the number. If I have €50 and I multiply it by the number 1, it doesn't do anything. I still have €50. But what they do is they strategically multiply by the number 1. And what I mean strategically is the number 1 can be written in so many ways that they write it like that. So that when they multiply the bottom line, what's √3 by √3? It's 3. What's 1 by √3? √3. So can you see there that that's just a fancy version? They're all fancy versions of the number 1. So they multiplied by the number 1, but they very strategically did it. They multiplied it so that when they multiply the bottom out here, they got a real number on the bottom line. What do you think would happen if you typed 1/√2 into your calculator? It would turn out like this. They are the exact same thing. So if they're the exact same thing, how do they go from here to here? Well, they took the original number and they multiplied strategically by the number 1. Multiplying by the number 1 doesn't do anything, but they need to be very strategic how they do it. So what do I need to multiply the bottom by to get this off the bottom? To have a real number on the bottom. √2 and √2. Is that the number 1? √2/√2? Yeah. Once you have the same number on the top and the same number on the bottom, that's the number 1. So 1 times √2 is √2, and √2 times √2 is 2. You can test all that out in your calculator. This is just a background to what we'll be doing when we do division of complex numbers.